Let's hope it worked. I'm hoping it's working. Here we go. Let's go. Okay, it's working. It's working. This is perfect. What's up? What's up? Let me know if you guys can hear me. Yo, yo, yo. Max, hello. And I hope I'm pronouncing this correctly. Saifu? Nice. It's working. Sound is good. That is awesome. Okay, we're here. We are here. That's exciting. Nice. Okay, we're just going to wait a little bit until some people hop on. I have my phone playing here. It's going live on TikTok just so people know to come join. But I think today we're going to be doing review for AP Calc, AB and BC, technically units 1 and 2, but I'm pretty excited about that. How's everyone feeling? Did anyone take, what was it, A push today? Or how were your APs this week? How are you feeling? That's what I want to know. Okay, I'm ending the TikTok. Give me a second. Yeah, whatever. All right, guys. Tick, go on YouTube. YouTube is where we're going to go. See you there. All right, guys. We're doing this. Hold on, let me just close this. I'm closing that. I just want to make sure everything's working. For some reason, I can't see the chat, but I think it's looking good. Yes, the infamous board. Okay, y'all can hear me, right? Ooh, Max, AP Physics on Wednesday. Nice. I'm glad that everything went well. A push was on Thursday, and people were pretty stressed about that, but I'm glad everything's going well. Guys, if you're coming from Discord, don't forget, if you have questions, we're going to be answering them from the Discord. So I'll probably, if you post any FRQs or questions that you might have, I'll pull them from there and then I'll put them on the screen, just so you know. So this is going to be our slideshow, but of course we can always, open anything up if we wanted to, if we want to, access a certain site so that we can practice problems. Keep in mind, everything is going to be from the Discord. Oh, I'm glad AP Stats was easy. It's very simple. The BC topic, I mean, you guys already know the hardest BC topic, in my opinion, is the series. Because every time they have like some weird questions. Last year's FRQ was pretty intense. Yeah, that one was the hardest one, in my opinion. That one was pretty intense. But just because it can always be confusing. But to be honest, with any FRQ, you got to take it slow. Just keep in mind, you know the material already. But yeah, man, it's going to be pretty exciting. I'm pretty pumped for you guys on Monday. And then I can't wait until we hear about the work that, or everything that you guys took. Or I can't wait to see the FRQs being released and stuff. I'm going to cut the music for now, just because I don't think we're going to need it. And royalty stuff, they might even not monetize the video, but that's not the point. Anyway, let's see. There seems to be enough people here. So for the channel, it's going to be the AP Calculus channel on Discord. That's where we're going to be posting. Again, you can post any problems that you might have that you say, this is what I want to review. So we'll go over those. But listen, here is my game plan, okay? My game plan is that I want to review, whoops, I realize that I'm not on here. Give me 1 second. I personally want to review units 1 through 4. We're just going to go over those. But of course, if people feel like in the comments, like, hey, we understand this already, let's just move on, let's do something else, that is totally fine with me. we'll do that. But again, I'm here for, I would say, maybe until 6, maybe a little more if we're having a good time. But yeah, man, I can't wait. Um, let's see. Don't forget, you guys can always post or follow me anywhere on the socials, and at the same time, we'll be answering any questions from Discord. That's going to be the most important thing. That if you have any questions, any particular questions that you say, hey, can you solve this FRQ? Post it on the Discord channel, the AP Calculus one, and then we'll just pull it from the screen and then just get working on that. Yeah, so here's the layout. Okay, just so you guys know. Let me go ahead and open this up. For some reason, this isn't working. Give me a second, guys. So I have my screen where I'm going to be showing you guys my slideshows. I have my iPad. Here we go. This is perfect. I'm going to have my iPad where we can work out problems. No whiteboard today. I really had that in mind, but it just didn't work out. 6, it's going to be time zone is going to be Pacific. I mean, so for 2 hours, I'm here for 2 hours, guys. So spherical coordinates is not on the AP exam, so I won't go over that today, but maybe later on, there could be a live that we can do, okay? Yeah, so let's just kind of get started, guys. I'm gonna continue yapping, but of course, if you guys see anything that you want to review, if there's a specific topic, or if there's something in the chat, again, just comment anything. Yeah, and we'll change it up. Again, we'll see how this goes. There is a system that I want to kind of have here. There is a structure or types of topics that I want to review, but if that is not something that anyone wants to do, they want to just do FRQs, then we'll do that. Awesome. All right, so let's go ahead and just get started. You know, if anyone hops on, they could always just, you know, go on. You guys can go on other. Give me 1 second, guys. Kind of screwed up something on my end over here. There we go. For some reason, something is. I'll figure that. No, we gotta fix that now. Sorry, guys, having some technical difficulties here with. Basically, it's my iPad. So let me just go ahead and fix that right now. Nope, that's not what I want. You're going to see that this is going to be critical that I fix this right now because we'll need it for sure. Okay, here we go. I think this, this is, perfect. All right, guys. So let's just kind of get started. Again, if you have any questions, let me know in the chat and, you know, we'll figure things out. But this is what I want to review today. AP, AB, and BC calculus problems, okay? We're starting from Unit 1, and let's just kind of talk about that. Unit 1 is all about limits and continuity, all right? And I have some topics that we should definitely know when it comes to the limit and continuity, and it's going to be some very, very basic things that you should know, especially for the MCQs. So let's just kind of talk about that. I know that for sure on the MCQ, they are going to give you problems where you just have to take the limit. As you can see, there's a particular question here where number 1, that is asking, you know, which of the following statement is false, and we have to just look at the graph and kind of work everything out as we go. The most important thing that you got to keep in mind, let me go ahead and switch this, is that, does this work? Perfect. Let me just open this up. Here we go. Okay. The thing you got to keep in mind is that whenever we're taking limits here, it has to approach the same value from the left and from the right. So for example, if we have this function here from the right and from the left, it's both approaching 4. So we would definitely say that the limit here as x approaches 4 of the function f of x is going to equal to 4. And it's actually as x approaches 1, I apologize. So keep that in mind. Again, if this is too easy, we can definitely start skipping over. If we feel like the entire chat just understands Unit 1, we can go ahead and move forward. But for now, just keep this in mind. One of the main things that you have to remember that when you're taking the MCQ, the limit from the left and right has to be the same, okay? It's not that it's continuous. This function is not continuous at that point, but you just have to know that it has to approach the same value from the left and from the right, okay? U-sub is not going to cook you. Trust me, U-sub is very easy, and especially, I'll talk about that maybe later on. But if they give you a U-sub problem, it's not something to be concerned about, to be honest with you. Okay, so just let me know in the chat. Do you guys want to review this particular question, question 1? I just kind of want to get a gauge, and then from there, we're going to talk about more problems. Or if everyone knows unit 1, we can definitely just start doing some MC or FRQs if you like. Yes, the piecewise continuous is definitely going to need more. Okay, we'll talk about the clarity one. We'll talk about exactly what you just mentioned, the unit piecewise continuous, and I have a problem on that. Okay, I'm going to skip this because I feel like we're good. So let's just kind of move on from this one. Limit to continuity. This part right here is technically a unit 2, but I know that they sometimes like to. Oh, okay. Never mind. Someone's asking if we can review it. So let's just kind of. I'm gonna go through everything, and then I have some FRQs. We'll kind of like cut in between, and we'll do an FRQ from there, and then we'll come back to the units. Okay. Yeah. So let's talk about what this one would be. You have a function here, and it looks like it's just piecewise, and there's like a bunch of things moving around. Whoops! I realized that I'm in the wrong. Let's go here. Okay. So you have a function, all right? It's just, it has a continuous or piecewise function, and they're asking for certain things. Which of the following statements may be false? I think the hardest part of this entire thing is the fact that we have to realize, oh, this is true, that must be the correct answer, and no, it has to be which one is false. So for the very first one, f of 1 is equal to the limit as x approaches 1. Well, if we look at f of 1, that's clearly equal to 3. We just look at the function, that's where it's 3. Okay? And the limit is also 3 because it's approaching the same value. So we can say, okay, this one is true. And this is where people get kind of messed up on. They'll say like, oh, okay, well, that is the correct answer. So that is A. No. You have to skip that. Okay? Because they're asking which one is false. If we go to the next one, f of 2 is 4. Because that's where is, I guess you can say like the point, right? It's not a whole. But the limit is not 4. The limit, it's approaching something from the left and right. It's approaching 2. So right away, we can say that this is going to be our correct answer. And just to touch on C really quick, f of C has a removable discontinuity at 2. That is true. It has a removable discontinuity because the limit is the same, or the limit exists, but the point is something else. And that's what the removable discontinuity is. Just imagine like you removed this point. Now you have a hole. And then for part D, f of x has a jump discontinuity at 4. Well, yeah, you can clearly see that at 4, from the left, it's 0, and then from the right, it's 1. So it jumps. So that's true. That's why the answer is B. Typical problem. Very, very typical problem. You're going to see one on the MCQ. Honestly, at this point, it's free points. All right. So let's go to the next one. Let me just erase everything here, and then we can go to the next problem. Let's go to this. Oh, like I mentioned, this is technically unit 2, but I just want to review it now. You're going to get a question with this limit, and a lot of people can easily just plug in 0 if they want to, and you're going to get 0 over 0. That's totally fine, and then you have to apply L'Hopital's rule, okay? So one of the things that I would say is that, okay, you can apply L'Hopital's rule, or just keep in mind that this problem is quite literally the definition of the derivative, okay? So the function that they're talking about is natural log of x. And why do we know that? Well, if you kind of just look at this, this is natural log of x plus h minus natural log of x. The function is clearly natural log of x. And when you're taking the derivative of this, it's going to be 1 over 4. Oh, I'm already getting ahead of myself. It's 1 over x, but then when you plug in 4, because that's really what it is, it's the derivative at 4, well then f of 4 is going to be 1 over 4, and we can clearly say that that's B. Again, you can totally do L'Hopital's rule, but this is a question that they'll give you. All right? All right, so let's go ahead and erase this part. So again, I mentioned if they give you a problem like this, 1, maybe 2, but just keep that in mind. All right. Questions that they love to ask, and this could be on the FRQ or the MCQ, okay, is I'm seeing a lot of questions where they say, what is the horizontal asymptote? And we have to keep in mind that when we're doing a horizontal asymptote, then we have to take the limit as x approaches infinity. So you're really just looking for when the function or what the value is when x approaches infinity, okay? Very important that we look at that. So you got to remember the tricks, all right? If the degree of the top, I guess I have it over here, if the degree of the top, and again, it's just literally looking at the degree here, so degree M and degree M, I meant degree N, degree M, they tell you right here, if N is less than M, in other words, the degree of the top is less than the degree of the bottom, then the x-axis is the horizontal asymptote. In other words, we'll say y is equal to 0. Option number 2, if they're equal to each other, then it's the ratio of the leading coefficients. In fact, that's exactly what this problem is. Notice that the degree is 4 on the top and on the bottom. Therefore, we're just going to have 3/7. That will be the horizontal asymptote. Okay? I'll look for an FRQ that looks something like that. And I see someone posted on the Discord of an FRQ that involves related rates. We'll talk about that in a second. All right? Let's just finish Unit 1, a couple more pages, and I promise that we would definitely cover that. All right. Now, this is a typical problem that they give you. Again, you can totally do L'Hopital algebra if you wanted to, but they're asking, if you notice, it's essentially the horizontal asymptote, so we have to keep that in mind. Now, how do we do it? Well, hopefully you can kind of see the trick there, that you're taking the square root of x to the 4th, which is x squared. So it has the same degree. So the horizontal asymptote, or the limit, will be the ratio of the leading coefficient. And in this particular case, it's square root of 9, because that's what we have on top, divided by the coefficient on the bottom, which is 1. So square root of 9 over 1, in other words, 3/1. And then the answer would be B. Typical questions. Typical questions that they love to ask. Okay. And I seen this on the FRQ where they give you, it could totally be just, it could be like a part D where they give you, a function like this and they say find the horizontal asymptote. In other words, go ahead and take your, or apply L'Hopital algebra if you need it, but you're taking the limit as x approaches infinity. Okay. I don't know why this repeated. I apologize. Now, there could be a squeeze theorem. We're not going to necessarily talk about like proving it, but there could be a squeeze theorem problem on here. Now, I don't have the particular problem that we have, or that I'm thinking about. But again, when it comes to the squeeze theorem, what I've seen happen is they'll give you two functions. They will already state it. Let me just draw a different color. They'll already say, actually they'll give it to you like this. They'll say the function f of x is between the two functions on the left and right. What's the limit? So all we have to necessarily do is just take the limit as x approaches that certain value. Okay? If they give you a squeeze theorem problem, it will more than likely be on the FRQ, whether it's like part D of question 2 or something like that. But the whole point is that it will be the last question on an FRQ. And all you have to do is just take the limit to the left and right. Okay? Now, here comes one that someone had mentioned that they want to do, is the piecewise continuous. You're going to see this on the MCQ. For sure, you're going to see that. So we have a piecewise function, x plus 5, where x is less than -2, and x squared plus kx plus 3, where x is greater than or equal to -2. Now, for these problems, they're asking, okay, let f of x be a piecewise continuous function. For what value of k will this function be continuous at 2? They already tell you that it's a continuous at 2, or they want us to find when it's continuous at 2. So what we have to do is keep in mind, we just want these functions to equal to each other. Now, you can go ahead and get, you can write the limit as x approaches 2 from the left. You can write the limit as x approaches 2 from the right. Guys, you don't have to worry about that for the MCQ. Okay? In this case, all we want is we want these values to be equal to each other when x is equal to 2, because the whole point is they want the limit to approach the same value from the left and right. So we just plug in 2. 2 plus 5 is equal to 2 squared plus k times 2 plus 3. And so let's simplify. This is 7. And then we have 4 plus, what would this be? 2k plus 3. Okay, let's simplify that. 7 is equal to 7 plus 2k. 0 is equal to 2k. 0 is equal to k. There you go. That's our answer. If they give you this problem, and I can guarantee it'll be one of the MCQs, what's the value of k so that the function's continuous? Boom, we found it. Okay. Let me go ahead and erase all this work, and then we'll go to the next one. Hopefully, whoever requested that, I think it was, I can't remember who it was, but hopefully that makes sense. Okay, so that's Unit 2. Now we're going to jump to, I'm basically going to jump to a Discord problem that someone sent. And this is an FRQ, and it's related rates. So we're kind of jumping to a different topic, but that's fine, because at this point, because we're studying these things, we should be prepared for any type of problem. Okay. So once again, at this point, I just pulled this out from the Discord. Thank you. I don't know if you want me to say your name, but thank you very much for sending this. This is, let's go ahead and show an FRQ from 2019. Now, an FRQ, will that show up on the exam? Perhaps. I don't know. We should definitely be prepared for something like that, okay? But there's a possibility that that's the case. But they won't make it as difficult as you might think. Let's just kind of look at this. So number 4, we have a cylindrical barrel with a diameter of 2 feet, contains collected rainwater as shown in the figure above. They always give you all this jargon, guys. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by this function. So we already know that dH over dt is equal to negative 1 over 10, or all that stuff, where h is measured in feet and t is measured in seconds. The volume of the, okay, so the good thing is they gave us the volume of the cylinder, which is pi r squared h. All right, so very first thing that we got to find is the rate of change of the volume with respect to time when the height of the water is 4. So let's go ahead. I'm going to go to the blackboard. Just because, you know, I want to be able to transition very quickly. I don't have the picture, but hopefully you can just, if anything, you can go back and just look at, you know, what we were, the drawing that we had, but it looked like this, guys. So we have a diameter of 2, we have the height, and then this was filled with water. Okay, and one thing that they told us, whoop, I didn't mean to erase it. Like this was filled with water. Okay, and one thing they told us was that dH dt is equal to negative 1 over 10 root h. Okay, so the volume is equal to pi r squared h, and what they want us to find is the rate of change of the volume with respect to time. All right, so let's just assume that we didn't quite know what was going on here. All right. So we're just going to take the derivative with respect to time. And if you notice on the right-hand side, we need to have, we have r. So we need to do product rule. Now, should I do product rule? I'm just gonna write it out, just assuming that I didn't see the trick here. Okay. So we're gonna take the derivative of the left-hand side, which is dv dt. In other words, 1 dv dt. And on the right-hand side, I'm gonna apply the product rule. So r squared times the derivative of h, which is dH dt, plus 2r dr dt, and then we have times h. Okay, so then what we needed to find is dv over dt when h is equal to, what do they say, when the water of the height is 4. All right. Now, I don't know if people noticed this already, but again, I know dH dt, okay? We don't know dr dt, but this is a cylinder. And one of the things you have to keep in mind with the cylinder, the rate is just going to be 0 because the radius will always be just 1. Diameter was 2, so therefore the radius will always be 1. That's it. So a lot of people can just say, oh, I'm just forget about putting the, like taking the product rule, just r is equal to 1 no matter what. So in other words, we can just say that v is equal to pi h. That's totally fine. In fact, you're going to see that would have been okay. Okay. So if you were to plug it in, let's just say I were to continue working on the equation where I did this. So we will have dv dt is equal to pi, and then we have our r, which is just 1 squared, dH dt, which is negative 1 over 10, root h was 4, and then we have plus 2 times 1 times dr dt, which is 0. So all that just cancels out. So then we have negative pi over 10 times 2, or negative pi over 5. And then we have to make sure we use the proper units here. The original problem, let's see, was doing height of the water, rate of the height of the water, feet per second. So we're going to go back and put feet cubed per second. There you go. And I'm hoping I got that right. That was part A. Yes, please. Someone said they'll be sending questions. Put them on the Discord. And Math Nerd, thank you so much. Our mod from the Discord is on the chat or in the chat too. And he's kind of helping you guys out. He's amazing. He's amazing, guys. Give him a shout out. Shout out to all you guys who are here. What a bunch of nerds. All right. So let's go to part B, shall we? Which is go back over here. Okay, so find the rate of change of the volume of the water with respect to time. Oh, I forgot to mention, if I go back to this, whoops, not this one, back here, I believe you will get maybe 2 points for this for taking the correct derivative, which will be 1 point here, and then getting the correct answer. So I believe this is a 2-point question. Someone can check the guidelines right now and say it in the chat exactly what it is, but I think that's what would happen, okay? So we're gonna go to question 2. Here we go. So when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Ooh, they love these questions. Okay, is the rate of change of the water, in other words, let's just kind of break that down. Is the rate of change of the water, in other words, is dH dt increasing or decreasing? Again, think about that. Is dH dt increasing or decreasing? Meaning, is a derivative of dH dt positive or negative? That's what we're really looking for, guys. So again, the real question is, for part B, is dH dt, or let me change it up, is dH dt, I'm just going to put prime for now, positive or negative? Again, I'm just writing these down in my own words, but one thing I would say for the FRQ, write as much as you can down. I think that will be very helpful. The grader will look at this and say, okay, I kind of see what you're putting there. I'll give you some points. Yeah, typically I think the more you write down, the better. Okay, well, we remember, if you recall from the problem, dH dt is equal to negative 1 over 10 root h. So we have to take the derivative of this. We can change it into negative 1 over 10, and then we can do h to the 1/2. I don't know why I put the parentheses there. But let's go ahead and take the derivative. So d squared h over dt squared is now equal to negative 110 times 1/2 h to the negative 1/2. So in other words, I guess I can just do negative 1 over 20 root h. But then, I forgot this. I should have done dH dt right after. Okay? So now we have to plug in h is equal to 3. Because remember, in the question, they were saying, is the rate of change at h is equal to 3 when the height is equal to 3? Well, let's go ahead and plug it in. So d squared over d squared h over dt is now equal to negative 1 over 20 root h times our dh, don't forget, was negative 1 over 10 root h. So we'll just plug that in to our equation. So we'll do negative 1 over 10 root 3. Whoops, I should have changed this h. I should have put a 3. That was the whole point. Okay. If you notice, some things do cancel out, which is nice. The root 3, the root 3. The whole point is that you're actually going to get a positive number. So we can just say greater than 0. And then because they do say to explain your reasoning, since d squared h over dt squared is greater than 0 at h is equal to 3, the rate of change of the height is increasing. Or is increasing. Maybe I should change my thing. I'm sorry, guys. Scribbles, math scribbles. It's that bad. But I'm gonna change the writing so it's a little thinner. I think that's what it is. The pen here was too thick. Okay. Nice. So that was part B. Let's go to part C now, the last one, and then we'll go and talk about unit 2. Okay. So let's go back over here. Part C, at time is equal to 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression of h in terms of t. It's funny, I've seen this problem so many times that I hope I got this right, by the way. I've seen this so many times that I forget what to expect. But gosh, they had a related rates problem, and they had a slope field or a separation of variables. That's kind of exciting. Okay, so let me just write the information down. So t is equal to 0. H is equal to 5, so dH dt is equal to negative 1 over 10 root h. All right, guys, let's bring it back to the blackboard. Here we go. Here we go. So we have to solve for the function. That's what we got to do. Separation of variables, guys. I always tell students, bring all the variables on one side, bring them out to, well, I don't know what I'm saying. I'm going to bring all the h's on one side and then all the t's on the other. So I'm going to multiply by dt to both sides, and then I'm going to divide by root h. These are just the way I like to write it. The cool thing is that when you start, people explain their work sometimes, they start showing different ways that they write this notation. And sometimes you kind of catch on, you're like, huh, never done that before. My teacher never did it this way. Cool, thank you. So let's go ahead and continue, where we will have, I'm going to do h to the negative 1/2. I am already anticipating that I have to rewrite that, is equal to negative 1 over 10 dt. And guys, this is it. This is the separation of variables. We can now integrate both sides. On the left-hand side with respect to h, and on the right-hand side with respect to t. That's the best part. All right, so here we go. We got, let's go ahead and add this. H, negative 1/2 plus 1 is 1/2 divided by 1/2. I'm just showing all the work, is equal to negative 1 over 10 t plus your cheese, or plus your c. Now, don't forget, you can put c's on both, but the idea is that when you have a plus c here, you're going to have another plus c on the other side. So if you subtract one to the other side, it's still just a constant. It doesn't matter. But again, because we're studying for the exam, we're not trying to like really think about the whole logic behind these things. Bro, just add a c on the right-hand side. That's what I would just say, especially because we're technically, you know, crunch time, I guess you can say. All right, so 2 root h is equal to negative 1 over 10 t plus your c. And here is where a lot of people like to solve for h, and then they're going to solve for their, or like to solve for c in this case, by plugging in your t and h. No, let me backtrack. I'm sorry, guys. I was reading something else. This is where people like to isolate the h already and then find their c. I don't like to do that. I personally like to find my c now and then go on. So I'm going to plug in t is equal to 0, h is equal to 5. So I have 2 root 5 is equal to negative 1 over 10 times 0 plus your c. So we have found our c. So then now we have 2 root h is equal to negative 1 over 10 t plus 2 root 5. Okay, let's divide everything by 2. Root h is equal to negative 1 over 10, negative 1 over 20 t plus root 5. And then now we can go ahead and just square everything. H is equal to negative 1 over 20 t plus root 5 squared, and we have completed problem C. Not bad. Whew, that was fun. That was fun. A toast to that. Okay. That was a good FRQ. Again, if you have any questions, go on Discord, okay? Go on Discord and post your questions there. That is exactly where I read them. This is where I got this particular problem from a user who had a question about FRQs and related rates and separation of variables, and here we are. We solved it. That was fun. Okay, so let's kind of start talking about Unit 2, all right? Just about the basics of that. And then if people are finding like an FRQ that they wanted to review, we'll go over that. I am totally fine with that. Okay, so let's go ahead and move on to the slide. Which, where did it go? Did I lose my images? You guys, I lost my slideshow. No. Oh, actually, no, I have it here. Let me go back to this. We're here. Haha. Watch this. Here we are. Okay. Let me just read some comments. If anyone, no, I think we're good. Guys, I want to thank you guys so much for being here. This is amazing. I'm so happy. I'm so fortunate that I'm now able to help. Just last year, a lot of people asked, oh, I wish you could have done something like this. But I already took the AP exam, and now you guys are benefiting from this. Every single year we get better. So thank you so much for being here. The support in general means everything, and I'll be able to help people to this year, next year, and the year after that. So let's talk about Unit 2. All right, Unit 2 is all about just knowing some rules of differentiation, okay? This is where basically it's genuinely the most basic, okay? You have to know some certain rules, okay? You have to know the limit definition of a derivative. I brought this up again because technically it is unit 2, but I did it for unit 1. All right. We already talked about this one, but if someone wants to review it, let me know in the comments or go on Discord, guys, on the AP channel. This is where a lot of the questions live. So don't forget, we have to know our basic rules of differentiation. If we don't at this point, we're going to be screwed. But most importantly, and I'm going to say this, you're going to have to know these rules, like the notations of the way these are written right now, the ones that you see on the screen. The reason for that is because on the next section, I believe is going to be unit 3, you're going to have to know how to take these derivatives. G of x times f of x minus, or g of x times f prime of x minus f of x g prime of x over g of x squared, because I know that they're going to ask you questions about that. All right, so keep that in mind. I want you to keep that in mind, that those are questions that they could potentially be asking. I know they're going to ask you that. And unit 3, I'll give you a problem that looks similar to that. Okay, let's not forget our basic rules for trig functions, dx, the derivative of sine of x is cosine, the derivative of cosine is negative sine. Gosh, if you guys don't know this by now, it could be trouble, all right? So along with this, the reason why we have to know this is because they're gonna ask you questions kind of like number 1, where they said, take the derivative of this, okay? It's a product rule. I don't even think we have to review it. I hope at this point, if you're on here, that you're fully prepared for problems like this. So you're going to have to know how to take these derivatives, okay? But then they'll ask you questions just like this one. Literally, this is an MCQ. If f of x is equal to 7x minus 3 plus ln of x, then f prime of 1 is equal to what? What's the f prime? Well, take the derivative and plug in 1. What's the slope? Okay, these are questions that they could possibly ask. This is unit 2. I don't know why this keep repeating. I'm sorry. And then here we go with like chain rule problems. If we have x cubed minus cosine of x to the power of 5, find the derivative. And though you can easily solve this, sometimes you're just going to have to simplify a little bit just to kind of understand where the, where you're going to have to simplify it, because sometimes the questions, the multiple choice, they will simplify it further. So you're going to have to do that work just to figure out which one is the correct answer. And now this is where things get interesting. I'm actually going to go over this one, 14, because notice that we have f of x is equal to this function, the root x squared minus 4, and g of x is equal to 3x minus 2. And they want us to find the derivative of the composite function f g of x at x is equal to 3. Okay, so let's go ahead and just talk about that. Well, what I would suggest is to go ahead and apply chain rule. I think it'll be much easier for us. Okay, so this will be f prime of g of x times g prime of x, and then you have to plug in 1, or plug in 3. F prime of g of 3 is equal to times g prime of 3. Okay, so then we have to go over here and just kind of figure out, okay, what is my f prime? Maybe I should do a red. Well, the f prime, don't forget, this is essentially x squared minus 4 to the 1/2. You're doing chain rule. This is 1/2 x squared minus 4 to the negative 1/2 times 2x. Well, the 2's cancel out, which is really nice. So this is just really x over square root of x squared minus 4. It's good to know that, because now what we can do, okay, maybe we can find our g prime of x is equal to 3. Well, now what we can do is we can plug all this in. Okay, well, g of 3, let's just figure out what that is 3 times 3 minus 2, so 7. So then we're really trying to find f prime of 7 times g prime of 3. Now we know g prime of 3, which is just going to be 3. And f prime of 7, okay, is going to be this function up on top over here. You just plug in 7. So 7 over square root of 7 squared, so 49 minus 4. Let's simplify that. Well, we got 21 over, and then 49 minus 4. I hope I did this right, because I'm not seeing any options here, but let's figure it out in a second. This will be square root of 45. Okay. This is why. Notice that none of these answers or this answer is none of the options. So we have to simplify this. We have to do 21 over square root of 45 is 9 times 5. So this is 21 over 3 root 5. So this will be 7 over root 5. There you go. So the option is A. There you go. Yeah, keep that in mind, guys. This could be a problem potentially. All right. So let me erase this. Can I possibly just erase Clear page. There you go. Yes, yes, I can. GoodNotes used to crash on me all the time, so I'm scared of even trying to do anything with it because it'll just crash and then it'll erase everything, and it's really frustrating. But anyway, here we go. So let's talk about Unit 3. Unless someone has an FRQ that they want to review, let me know. I can also just find something real quick. I can find an FRQ just to kind of get things going. Let's find let's see. Someone posted, let's check the pinned comments. I know someone posted an FRQ recently. So let's just go ahead and review those. Oh, I guess those are the only pinned comments. Okay. All right, so let me just find an FRQ on anything really. Maybe we could do last year's FRQ. Or we can do, since we're on the subject, maybe we can do some implicit differentiation because that is going to show up. Might as well just jump ahead and do a problem like that. What do you guys all think? Let's do... we just did a differential problem like this. Yeah, let's jump to this one. Okay, here we go, guys. We're gonna do this problem right here. Someone said inverses. Okay, let me just read some comments real quick just to kind of make sure we're all good. But again, if you have any questions, you can answer them or you can post them on the Discord. So someone said the main FRQ topics to expect are related rates, optimization, disk and washer method, FTC graphs. Yeah, that's totally true. I agree. Those are good topics. Inverses. Thank you, Soapwall. Thank you. You're the best. Okay. So let's talk about this one. This one shows up many times. You're gonna, on that topic, someone mentioned that there's gonna be a graph relation. It's actually going to that. Let's just kind of show what that is. Okay, let me zoom in a little bit, and I want you to just kind of look at this problem. I'm sure maybe you already did this, but let's just review it because again, reviewing things now is gonna be super helpful. Okay. Reviewing things now is going to be super helpful. It could bump your grade from a 3 to a 4, a 4 to a 5. This is it. This is perfect. Okay, so let's go ahead and review that. So what we have is we have this graph. And keep in mind, this graph is of f prime. Okay, so the function is defined on the closing interval -2 to 8 and satisfies f of 2 is equal to 1. That's going to be important. When they tell me, or when they give you the f prime and they tell you an initial condition, that's because you're going to be expected to take an integral soon. I assume that's what will be the case. Okay, the graph of f prime, the derivative of f consists of two line segments. So they give you straight lines. Typically, they're going to be straight lines, or they're going to be like circles. Okay, half circles. So now question A, does f have a relative minimum, a relative maximum, or neither at x is equal to 6? Well, let's just talk about that real quick. I realized that my iPad was turned off. Let me turn this back on. Okay, so let's talk about what that means. All right. So when something has a relative minimum, 1, I guess what we should say, it should equal to 0. Maybe I should do f of x is equal to 0. And in this case, we're trying to find if f prime of x is equal to 0. So that's the first thing we should look at. So let's look at our problem. Let's see. On the graph, you'll notice that f prime of 6 is equal to 0. And that's going to be perfect. That is equal to 0. So check. Okay, we can already say check on that one. Okay, but now, is it going to be a minimum or a maximum? I typically, you can just do a number line here, and you just got to test x is equal to 7, x is equal to 5, one number on the left, one number on the right, and you want to check whether it's increasing or decreasing. Is the derivative positive or negative depending on what we have? Okay, so let's just go back to our function, and you'll notice that at 5, we don't know what the value is, but it's positive. And the same thing for 7, it's positive. Okay, so I'm going to go back to our problem. We have positive and we have positive. So it's neither a minimum or a maximum because it continues to increase and then it continues to increase again. So the function may look like something like that. So then to answer our question, we will say neither min or max. And then so we can say since f prime does not change signs. So we know that 6 is a critical point, but we don't know, or we just show that it doesn't change signs, therefore it's not going to be a critical point. Okay. Okay, someone just posted a problem. I'll make sure that I do that in a second. Okay, we'll do that FRQ soon because it seems like, unit 2, it's all just derivatives. Again, this is exactly why we're here. We want to practice these. I feel like the MCQs are pretty easy. Okay. All right, so let's go back to the slideshow or our picture here. And what we have is on what open interval, if any, is f concave down? All right, f is concave down. So you got to think f, it means the second derivative. In other words, the derivative of this. Well, let's just kind of write this down really quick. I keep going back to the wrong one, sorry. So for part B, okay, we're looking for concave down. So we want the second derivative to be less than 0. Okay. And when is that going to happen? F prime is decreasing. We kind of, again, I'm just writing my train of thought. Oh my gosh, I'm going to write on, sorry, decreasing. Okay. That's what I'm looking for. So if we go back to our picture, when is it decreasing? Well, it's decreasing from -2 to 2, or -2 to 0, I'm sorry. And then it's decreasing from 4 to 6. And that's when it's concave down. Okay. So go back to this. We say -2 to 0 union 4 to 6, since f prime is decreasing. I don't even think we need to justify anything else. They were asking for concave down. That's what we gave. That's it. Hopefully you guys would agree. So for the next one, find the value of this limit. This is actually, I did make a video about this, was not expecting this problem to be here, but I'm just going to write this down. So we got the limit as x approaches 2. And honestly, if you have a problem like this, especially with limits, it's because they want you to use L'Hopital's. Quite literally, that's what they want. So we have x squared minus 5x plus 6. So let's just go ahead and first plug in 2. That's the first thing we want to do. Okay, just to show, well, that's the case. So we have 6f of 2 minus 3 times 2 over 2 squared minus 5 times 2 plus 6. Okay, on the bottom, I can already tell that's going to be 0. You can kind of do some basic math there. And then on the top, we have 6 times f of 2, which, by the way, I did say that we had to find an integral. And wow, I guess I've been proven wrong because they already give us that f of 2 is equal to 1. They tell us that just up here. F of 2 is equal to 1. Okay. So since f of 2 is equal to 1, we have 6 minus 6 over 0. In other words, 0 over 0. So we have to apply L'Hopital's. So we can just put LH. And then so we have the limit as x approaches 2 over, or I put over. I was already taking the derivative of the bottom. But let's just do the top first. 6f prime of x minus 3 over, and then now we have 2x minus 5. So we have to go ahead and plug in 2. 6f prime of 2 minus 3 over 2 times 2 minus 5. On the bottom, let's just simplify that. That's -1. And then on the top, we just need to find the value of f prime of 2. Well, luckily for us on the graph, they give us f prime of 2 is 0, which is really nice. So we're done. We're done. We found f prime of 2, which was 0. So we have -3, because 0 minus 3 is going to be a -3. So that we get 3. Sometimes I feel like I have to justify some basic notation there. Like, oh, -3 over -3, that's a positive. Or, 0 minus 3 is -3. Sometimes people get super confused. So I apologize if that sounds so silly. But okay, that is part C. Let's go to the last one. Now we got to go back and figure out, find the absolute minimum value of f on the interval. So absolute minimum. When I think of absolute minimum or maximum, we need to do the candidates test. Okay? So we need to find absolute min on -2 and 8. Well, first thing we got to do is we got to find the critical points. Okay, so I'm going back over here so you guys can see what I'm doing. Okay, so when does f prime of x equal 0? And I'll show you on the graph in a second, but that's -1, that's 2, and then that's going to be 6. Okay, that's f prime of 6. Oh, I kind of already, I did say integrals, and here I am. But we're about to do an integral. You're gonna see why in a second. But this is -1. That's why it's equal to 0. That's a critical point. We have 2, and then we have 6. Not bad. All right. Now let's actually solve for these values, because unfortunately what we got to do is we got to find f of -2, f of -1, f of 2, and then f of 6. Now remember, yeah, we need to find these values because these are going to be absolute, because the candidates test tells you that you need to find the values at the original function. Well, we were only given the graph of f. That's the unfortunate part. So what sucks is that we are going to have to do integrals here, because we're going to do the integral from 2, well, I guess I can do -2 to 2 of f prime of x. And the reason why I chose 2 all of those is because we know something about that. Okay, we know that this will equal to f of 2 minus f of -2. We know f of 2, which is going to be 1. That was given to us in the very beginning. So unfortunately, or what we have to do is we have to go to our slideshow, or I keep calling it, I call it a slideshow on my screen here. So we have to go back to our problem. I should say that. And we need to find the integral from -2 to 2. Well, I don't know if you can see right away that we have a triangle that's above the x-axis and a triangle that's on the bottom of the x-axis. So if you were to find the area between these, because again, we're taking the integral, so we have to take the area underneath the curve, these two areas will cancel out. So we have 0, and then we have a triangle here with a base of 2 and a height of -2. So that's going to be -4 divided by 2. So we have -2 here. Okay, that's our entire area from -2 to 2. So we have -2 equals, and then we have 1 minus f of -2. But we have to go ahead and do -3 is equal to f of -2. And so we have, let me put it up on top over here, and f of -2 is equal to +3. Okay, maybe I shouldn't even circle that. Yeah, maybe I mean, I'm just going to leave a circle, but I wouldn't suggest you circle until the very end, because you have to show your answer. Okay, so now we have to find f of -1. Well, we know a couple of things already. We can go back to our picture. I'm just going to erase this. We know f of -2, which was 3 already. So now we can do the integral from -2 to -1 of f prime of x, which again, this is f of -1, which is what we're trying to find, minus f of -2, which we know is 3. So going back to our diagram, f of the value from -2 to 1, this will be an area of 1. Why? Because you have a base of 1 and the height of 2. So 1 times 2 divided by 2, that's going to be 1. So that's our height. So then we have 1 equals f of -1, which is what we're trying to find, minus 3. So add that, 4 is equal to f of -1. Okay, so f of -1 is now equal to 4. Again, maybe you shouldn't circle it or box that in, but we're almost there. Okay, for this next one, the integral from 2 to 2, I want to use that just because we know that 2 is equal to 1. This is just going to be 0. So we're good there. So then f of 2 is going to equal to 0. And then now we can do the very last one, which we can do an integral from, let's go ahead and do, oh, that's kind of annoying, 2 to 6 of f prime of x. And by the way, over here, it was f on the integral above. It should have been f prime. Okay. Oh, I do have to find f of 8. Thank you. Someone's asking that I need to find f of 8. Yes, I do need to find f of 8. Oh, okay. I feel like that's our minimum is gonna be 2, just because these values are now gonna continue to increase. Maybe I don't know if we can justify that, but basically that's what it is. But let's go ahead and solve that. Thank you so much for bringing that up. Okay, so if we're gonna do, we were doing f of 6. So the integral of f of 6. We know that this is, let me bring this up to the top over here so I can have space. So we have integral from 2 to 6 of f prime of x dx is equal to f of 6 minus f of 2, which again, we know that's equal to 1. Oh, this is the annoying one, guys, because you need to find the area from 2 to 4. So 2 to 4, that's going to be an area of 2, because again, it's a triangle. So 2 by 2 divided by 2. So we have an area of 2, and then we have to take this, like this value over here. And what you have to do is you're going to have to take, let's just say, for example, the area of this quarter circle with a radius of 2, and then subtract it by, or I'm sorry, you're going to have to take the area of the square, which is a 2 by 2, and then subtract it from the area of the quarter circle. That's really annoying, but we're going to have to do it. So we know, for example, that this will be, we had said 2 plus, and then we have 2, or I'm sorry, 4 for the square, minus, and then we need to subtract the quarter circle of a circle with radius of 2. So pi 2 squared divided by 4. And that's equal to f of 6 minus, and then I'm just going to put 1 because that's our f of 2. So what we have here is we have 6 plus 6 minus pi, and then is equal to f of 6 minus 1. So we have 7 minus pi is equal to f of 6, which again, we're looking for the absolute minimum. So it looks like the minimum is already going to be our value, which is going to be f of 2. But I feel like we need to justify that that's the case. So f of 6 is 7 minus pi. That's like around 3. If we do the next one, f of 8, just for the sake of kind of continuing on the next problem, unless you guys really want me to do it, well, actually, I'll just kind of explain that one. I guess we could do like the integral from, if we go back to the slideshow, you can do 2 to 8 again, or you can do 6. I guess we can do 6 to 8 because we know what that is. So 6 to 8, we know the area underneath the curve, which was the same area from the other one, which is 4 minus pi. So we'll just do that one real quick. So if we wanted to do, let me just erase this. If we wanted to do f of 8, what I would do is integral from 6 to 8 of f prime of x dx is equal to f of 8, which is what we're trying to find, minus f of 6. Let me just erase a couple things. Now, again, we already know what this area is because we sort of did it in the previous problem, is 4 minus pi is equal to f of 8 minus, and then 7 minus pi. That's our f of 6. Okay, final problem. 4 minus pi is equal to f of 8 minus 7 plus pi. I guess I can add the 7, so 11 plus minus 2 pi is equal to f of 8, which again, 11 minus 2 pi, that's like 11 minus 6. That's still 5. So our absolute minimum will be 2. I'm trying to write all of our work in this page, but I feel what you should do at the very end is say what your absolute minimum is going to be. Yes, I'm using net change theorem. So one of the things that we should do every time we have problems like these is that if you're given the graph of f prime and you're given an initial condition, more than likely you're going to have to use net change. It's that simple. Okay, that is it. All right, so let's just do another FRQ. What do you guys think? Someone just suggested an FRQ. Wow, I'm getting 2 different FRQs. This will just be an FRQ because it looks like unit 1 through 4. I feel like everyone understands that. I will talk about an implicit differentiation that we should definitely know, something that I feel that is just important. But for now, we're just going to jump to an FRQ, another FRQ. What do you guys think? It'll be this one. This was suggested by, I don't want to say the name, but they know who they are. Thank you so much. Wow. This is an interesting one. Here we go. So let's see. We have a company designed spinning toys using the family of functions. Okay. So we're just using that particular function where C is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the y-axis, and the graph of y is equal to this. Okay. Each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. Wow. Again, I feel like I've seen this problem before, but when I see it, it's just so exciting. When I see it again, I get pretty pumped up about that just because I'm like, oh, I guess we're looking for a volume. I honestly thought this was going to be an implicit differentiation problem. Okay. So each spinning toy is in the shape of the solid generated when such a region is revolved. Okay, so it's going to have a volume. But the first thing they want us to find is the area of the region in the first quadrant when C is equal to 6. Now, on Discord, can you tell me whether or not this was, or someone on here on the chat, is this a calc section or a calc problem? I don't know if this is a calc. I'm just wondering, just because I feel like I'm gonna have to plug in into a calculator. There's no way that they're gonna want or like require this of you on the FRQ to show all your work. But anyway, we need to find the area where it's bounded when C is equal to 6. So what we really have, let me just kind of draw it out and then I'll show you guys, is we have a function like this. We don't know where this is, but y is equal to 6x root 4 minus x squared, and then we have to find the area. Okay, so the main thing is we don't have these points. Okay, I'm just gonna ask this person if it's a calculator portion. Yes, okay, someone says if it's a calculator. No, okay. I'm gonna assume that it's a calculator problem, but anyway, this is what we're looking for. We're trying to find the area. So what we need to find is we need to find where it intersects. So I am gonna have to assume that we're using a calculator for this one, just because I guess we can set it equal to 0, which is 0 and 2. Okay. Okay, so I wouldn't think if this is a calculator problem. Let me just look this up. I don't want to look up the answer, but what do you guys think? It's question 3. So calculator. Someone link the Discord in the chat if possible. It's a no calculator. Damn. No way. Okay. No calculator it is. Wow. No calculator portion is diabolical. Okay. Well, I guess going back to this, when does it equal to 0? Well, you can easily set it equal to 0. And we get that x is equal to 0, which is expected. And then you can set the other one equal to 0, and you get 4 minus x squared is equal to 0, and you'll get that x is equal to plus or minus 2. Now, it's in the positive x-axis because it's in the first quadrant, so we're going to assume that this is x is equal to 2. Okay, so for part A, they want the integral from 0 to 2 of 6x root 4 minus x squared dx. What year was this? This is 2021. Wow, I'm surprised. Okay, no calculator. Jeez, that is crazy. Okay, thank you for letting me know. No calculator, thank you so much. Wow. All right, here we go. Well, guys, first time I have not seen a use sub problem in a very long time like this on the FRQ. So if they show this up, I mean, it's only been 5 years. Good fucking luck. But it's not that hard. It really isn't. Okay, so u is equal to 4 minus x squared. Right away, it should be a simple u sub where our du is negative 2x dx. And let me just change our bounds. So when x is equal to 0, u would be 4 minus 0, so 4. And then when x is equal to 2, u would be 0. Okay, that's not bad. Let's change this up. Let's just put it up on top over here. So we're doing the integral from 4 to 0. These changed. 6x root u times, and then we're going to have, I guess, let me go back to this differential, that part right there, and let me go ahead and divide the negative 2x. So du is equal to negative 2x is equal to dx. And the reason why I like doing that is because when I go back to my integral back on top, when I write my dx, well, I'm just going to do du over negative 2x. I like this because I kind of see like, okay, I see what cancels out. For example, the x's on the top and bottom. The 6 and the negative 2 become a negative 3. So we have negative 3, 4 to 0 of just u to the 1/2 du. Now, the good thing about this negative is that it switches the bounds. I can do 3 integral from 0 to 4 of u to the 1/2 du. That's not bad, right? Okay, so then now we just take the integral. So this will be u to the 1/2. Well, actually, no. Whoa. 3/2 because you have to implement the power rule. And then times 2/3 from 0 to 4. Okay, that's not bad. You plug in the 4. So it's going to be 2 times 2/3. And then you plug in your 4 to the 4/3 minus 0 because you get a big fat 0 when you plug in the 0. So 3's cancel out, but then you have 2. Let's see. This will be 8 because the square root of 4, or actually, I feel like you can leave your answer like this if you wanted to. But anyway, it's the square root of 4, which is 2. Cube it, that's going to be 8. So now we have 16. That is part A. Guys, if this is on the FRQ, whoo, wow. That's crazy. That will be pretty insane. Pretty insane. Once again, guys, you guys can post your stuff on the Discord. Someone was asking about the Discord in the chat, so if anyone has it, just link it. That will be great. But that's crazy. Okay, let's go back to the next problem. It is known that for C, the derivative, thank God they give us a derivative already, for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of C for this spinning toy? What the freak are they asking? It is known that for this function, the derivative is this. Okay, gotcha. Thank you. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value? The radius of the... Wait, so I'm missing something about the radius. Very quickly, someone's asking the f of b minus f of a. So this, I'll explain that in a second. Anyway, let's go back to this. Someone's asking, wait, I'm just... It's revolution of volume? It sounds like it. It is known as the largest cross-sectional circular slice. So it's a circular. What is the value of C for this spinning toy? The radius of the largest cross-sectional slice. What is the value of C for this spinning toy? Well, okay, so here's my understanding. And maybe I can get this wrong. But, whoops, if I go back to my blackboard here. If I were to draw this, okay, let me just do it again. We don't know the value of C, so the graph looks something like this, okay? So they're saying that the largest radius, this value up here, is 1.2. Right, so something about maximum. So they're saying that the max value over here, or the y value for the max value, is going to be 1.2. That's how I'm understanding it. Because they're saying the derivative. So basically, if this is the max value, then the derivative is equal to 0 at that point. That's my understanding. This is when they give you some problems and you're like, what is going on? Someone's asking about the fail rate. Yeah, I can see this one was tough. Okay, well, let's talk about this real quick. Okay. All right. So again, this was my understanding that it is the maximum value. They tell you that the radius, because yes, this is revolving technically, but they're just saying the radius of the largest cross-sectional slice. So they're saying if you were to do like the volume, or if you were to rotate this all the way, then the radius is 1.2. So they're saying that when the max is equal to, or when the derivative is equal to 0, the radius, in other words, the y value, is equal to 1.2. So let me just write this. When dy dx is equal to 0, y is equal to 1.2. Okay, well, we know a couple things. They told us that y is equal to cx root 4 minus x squared. And then they told us that the derivative, which again can be shown, is c 4 minus x squared over root 4 minus x squared. Okay, well, when the derivative is equal to 0, the top is equal to 0. So let's just solve for that. C 4 minus x squared is equal to 0. Well, that's just when x is equal to 2. which is also a relative, which is also making the function. Oh, whoa, 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 whoa. There's a 2 there. I'm sure someone's already commented about that. Guys, look at the top. The equation should be 4 minus 2x squared. Okay, so that will be so much better because x does not equal to 2. So 4 minus x squared, 4 minus 2x squared is equal to 0. Then we have negative 2x squared is equal to negative 4. I'm just going to show all my work. X squared is equal to 2. X is equal to plus or minus root 2. Okay, so x is equal to root 2. That's when you have a maximum. So now we're going to plug that into the original function. So now we're going to do 1.2 equals c, and then instead of using this function, now we're going to go ahead and plug in the square root of 2. So 1.2 is equal to c square root of 2 times 4 minus square root of 2 squared. 1.2, which I guess I'm just going to do it as 12 over 10. I don't know if we're going to need that. C root 2, and then we have square root of 4 minus 2, so square root of 2. So 12 over 10 is equal to c times 2. Yo! So we can divide the 2 to the other side and get 6 over 10, or 0.6 is equal to 6. Or 0.6 is equal to c, sorry. Wow. Wow. That was crazy. Someone's asking if we're doing review. Honestly, at this point, this is review. We're just having a hangout. I don't know. I have a game plan of like just going over units, but this is just a review. See it as that. To be honest, the more we learn, and I would even suggest as you have something as you're watching, hopefully you have a pencil or a pen of your own, and then just practice away. Okay, but now let's go to part C. This one was tough because the question here was a little tricky. Part C, for another spinning toy, the volume is 2 pi. What is the value of C for the spinning toy? Now I think we're getting to volume. So keep in mind, at the very top, they said each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. So let me just draw it out again, and then I'll show you guys my picture. We have y is equal to cx root 4 minus x squared. And then now, let me go back to the blackboard. They're saying that the volume, which is equal to pi integral from a to b of cx root 4 minus x squared dx is going to equal to 2 pi. Because remember, this entire thing, you have this region, is being revolved about the x-axis. So we're basically doing the disk method here. So let me just divide the pi to the other side. So I have 2 is equal to, and then I believe at this point we have already mentioned that from part A that our points are going to be 0 and 2, which is really nice. Okay, so then now what we have to do is we have pi integral from 0 to 2. We don't know the c value. Whoops. And I realize that this entire function needs to be squared. Because again, according to the disk method, pi integral from a to b of the radius squared dx. All right, so let's go ahead and plug this in. C, we have x root 4 minus x squared. And then we're going to square everything. Let's just use correct notation here. 2 is equal to, guys, the pi went away. We have 0 to 2. And then we have c squared, x squared, and then we have 4 minus x squared. So the root goes away. Okay, that's not terrible. 2 integral from 0 to 2 of c squared. And then let's just erase this. 2 is equal to, let me pull out the c squared, integral from 0 to 2 of 4x squared minus x to the 4th dx. Okay, not bad. I kind of like this one. 2 is equal to c squared. Let's just start integrating this. This will become 4x cubed over 3 minus x cubed over 5 from 0 to 2. This is a non-calculator portion. That's pretty cool. 2 is equal to c squared. And then we have, okay, we plug in the 2. So 4 times 8 over 3 minus 32 over 5. And then when you subtract the 0, that just goes away. Guys, this is crazy. But let's just, how about we multiply everything by 15? just to get rid of the common or the denominators there. So 30 is equal to c squared. And then we have 32 minus, wait, that doesn't look right. What did I do wrong? What did I do wrong? 4 times 2. Oh, I multiplied by 15 and I didn't when I multiplied the 15 to this one, I also should include a 5 because the 3's cancel out, and then this should include a 3. Wow. Okay. I guess maybe they're expecting people to get that wrong, kind of like I did. So, let's see. This will be 160 minus, and then this will be 696. So then I'm just going to, again, a non-calculator portion. So 30 over 160 minus 96, because we're taking the square root, that's our C value. Yikes. Yikes. This is crazy. This was a crazy problem. Wow. Okay. So I think we still have time. I want to review, which one do I want to review? I want to review Unit 3. Let's go back to Unit 3 real quick, and then we'll do another FRQ. And once again, I will mention it. If you have any questions, I'm answering those questions from the Discord. So go on the Discord if someone needs to know, where or what the channel is. Hopefully someone drops it in the chat. Let me just answer this question real quick. Where did the x to the 4 come from? So what I did is I'm just going to direct you to this step right here. Okay. What I did is I distribute the x squared and the x squared to both terms. And that gave me 4x squared minus x to the 4th. Hopefully that answers that. Yeah, this was tough. This was tough. This was tough, guys. Okay, we done Unit 1, Unit 2. We can talk about Unit 3. That was crazy. Let me just respond to this person. Crazy. A non-calculator portion? That was insane. Okay, someone else had posted a FRQ that we're definitely going to do. It looks like it's problem 1 from 2028. Yeah, we can actually, what do you guys, let me know in the chat. Do you guys want to kind of review just some basic Unit 3, Unit 4, like multiple choice questions, or do you guys want to do an FRQ from 2018? Yeah, hopefully it's not this bad. This was pretty crazy. This was just insane. Insane. Yes. So someone's asking, was a cx squared given in the equation? Yes. Actually, I'm going to go back to the point. This was the problem. Okay. Okay. If someone has a Discord link, I know there's people here that were on the Discord. Put that invite on there, or just go to the link in my bio anywhere. Whether it's here on on YouTube or my Instagram, my TikTok, it's on there. Yeah, but someone linked it already. Okay, let's do an FRQ 2028. Did I say 2028? Yes. Oh, wait, or did I say no? Maybe. Okay, Francis, let me link it for you. I got you. Hold on. Let me get off this chat here. Okay, and you're gonna go, just as I let you know, you're gonna go to the AP Calculus channel that's on there. Okay, there's a bunch of you nerds that are just practicing away. There you go, linked it. Okay. I love that it corrected you. I love that it corrected you too, Travis. All right, here we go. This was the problem, guys. This was the problem that someone on Discord sent. I won't say their name, but thank you so much. I don't know. Maybe I can't. Oh, oh, yep, gangster. All right, here we go, guys. We have a Calc AB problem. This, I think, could potentially be a BC problem as well. And I've seen this one. I remember I was actually helping a student out who ended up getting a 5, which was really nice. Hope he's doing well. Okay, so people enter a line for an escalator. I'm already seeing this is an in and out problem. Something is entering, something is exiting. That is going to be fun. All right. So we have they're entering at this time from 0 to 30. So it's going to be 0 to 30 seconds. As people get on the escalator, they exit the line at a constant rate of 0.7. So let's talk about that. They're exiting the line at a constant rate of 0.7. Keep that in mind. They're exiting the line at a constant rate of 0.7. Okay. So R is the rate at which people enter. Where people enter is given by, wait, I just got lost here. Where R(t) is measured in people per second. Yeah, so R is a rate. A lot of the times on the FRQs, they don't tell you this is like R prime. We have to assume this is already the derivative. Okay. If this is a unit where you have to know whether the speed is decreasing or increasing, no, that will be like a particle motion. Well, they can potentially ask that, but this, I like to call it the in and out problem. Okay. So here we go. R(t), again, people are entering at a rate. This is already a rate. And then people are exiting at a certain rate as well. And then there are 20 people in line at t is equal to 0. So it's important to know all these things, right? You got to gather all your information. How many people enter the line during the time 0 to 30? Well, remember, how many people enter the line? They already gave us the rate. So what we need to do is we need to find the integral from 0 to 300 of r of t dt. Okay? That's what we need to find. So I'm pulling this up. I'm going to go on Desmos real quick, and I'm going to type this up for you guys. So I think it's important that we have these. Maybe this will be a great time for you to practice. But I have Desmos. I'm going to go ahead and put this entire thing, 44, and then we have t over 100 or x over 100. I don't think Desmos allows you to put t to the power of 3. And then we have 1 minus t over 100, 1 minus x over, 300 to the power of 7. So it's important to kind of have this equation done right. It looks like that's correct. Okay, so what we need to find is the integral from 0 to 300. Why? Because this is how we find a total accumulation. All right, so how do we write it? INT, integral from 0 to 300 of r of x dx. It's better to just write r of x dx like this because it gives you the equation. How can we be sure when to do an integral? Well, in this case, again, it's all about kind of recognizing patterns. Because they were asking, this is entering at a rate. Again, these problems in and out, they're already representing the rate at which something is entering. Okay, so then if we're trying to find the total amount, the total amount of people that entered between 0 and 300, well, they're talking about the rate. We don't know anything about the original function, so they already gave us the rate. We should start thinking about that we need to take the integral because the integral finds the total accumulation based on the rate. Well, Luke, thanks for being here. All right, so for part A, how many people enter? We found that out to 270. Again, I just took the integral of the function. I think it's important to kind of do this on Desmos. I like to draw or write out the entire function already, just because I can take my derivative if I needed to. Whoops. It'll be like f prime of x, and it tells me my derivative, let's just say at like 2. I don't know, I'm just giving you an example. It's nice to do that versus like I don't have to take the derivative of this whole thing. Okay, so now, here we go. For part B, during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time t is equal to 300? So this is where we kind of need to understand the equation that we should create. So I'm going to go back to my blackboard. For part B, we need to write an equation. I'm just going to call it total amount of people at some time or at x. And that's going to equal to the integral from 0 to x of the people that enter minus the people that exit. I'm just going to put e of t. Oh, yeah, e is fine. You have to create a different equation because, again, r of t was given to us, but e of t was equal to 0.7 because this was the rate at which people are exiting. And then this will be the total amount of people that exit and leave at the same time. So this is the total amount of people based off how many are entering, how many people are leaving. But then we have to include that there was 20 people in the very beginning. Okay. Kale, nice to see you, dude. All right, so they're asking during the time there are many people. How many people are in line at time t is equal to 300? So for part B, we need to find the integral from 0 to 300 of r of t minus, I'm going to have to put 0.7 dt. Now notice that I left it as r of t because r of t is defined. Your grader will know what r of t is, but 0.7, if I leave it as e of t, maybe they won't know, even though I put it up on top. And then plus 20. So let's go back to our Desmos. This is like the calculator ones are so much easier. So we have this. Maybe I can just do, whoops. Maybe I can just do this and I can put minus 0.7. Minus 0.7. And then I'm going to put plus 20. So there it is. There's going to be a total of 80 people. And in fact, what I should have done is for part A, I think it was 270 or something like that. I should write people. And then for part B, I should write 80 people. That's it. That's a good question. Isn't it 0.7 t? Now let's go back. Okay. Let's go back to that question. Isn't it 0.7 t? Notice that that's what they expect you to do. Because look, they're exiting at a constant rate of 0.7. Oops, sorry, over here. They're exiting at a constant rate of 0.7. So this is the rate already. So we need to write the equation of the rate. So the rate, I guess you can say the velocity or the rate at which something is changing is 0.7. The total amount of people can be modeled by 0.7 t. So you have to write 0.7. They're expecting you to do that. All right. Someone's already posted another FRQ, which we'll do in a second. We got time for sure. All right. So hopefully that makes sense. But again, 0. Yeah. Awesome. Thank you. I'm not going to repeat that name, but you know who you are. Okay. So you got to remember that when we take this, when we did our Desmos, we found the integral from 0 to 300, r of x minus 0.7 plus 20. We need to include that, that initial amount. Okay. So now let's go back to part C. So for t is greater than 0, what is the first time that there are no people in the line? Okay. What is the first time there are no people in the line? Well, you got to remember, okay, let's go back over here. Keep in mind, there's at 300 or at time 300, there's 80 people. So now what we'll do for part C is we have 80 people minus, technically, if you wanted to, you can do, actually, let's just say, I'm just going to write an equation like this. F of x is equal to the amount of people that we have minus the integral from 0 to x of 0.7 t dt. Okay, I like to write it this way just because, you know, this is the way I like to think about it. And the reason why, notice that I didn't include the people entering. And that's because, if you go back, after time 300, no one is entering. We're done. So that's why I went back over here. Whoops. 80 minus, and now all I'm doing is, whoops, I put 0.7 t. No 0.7 t. That was an issue. Okay, so now we're going to take the derivative because they're asking at what time. Oh, at what time is there no people? I'm sorry. If I were to take this, I do 80 minus, this will become 0.7 x, and that's it. Again, why? Because if you were to take the derivative of this whole thing, this will be 0.7 t, but then you're going from 0 to x. We don't know what time, and that's 0.7 x. So then all we have to do now is just find when are there 0 people. Well, let's go ahead and subtract the 80, negative 0.7 x, and we use our calculator to divide that. I'm just using Desmos because that's what's available to me. divided by 0.7. Whoop. A different tab. This. Yeah, there it is. So 80 divided by 0.7. And we find that it is 114. So you guys, my bad. 114 point 28 or something like that, or 285 is equal to t. Because remember, for the calculus problems or for the FRQs, for these you can just truncate it to 3 decimal places. You're good there. Okay, that's part C. This is it. All right, so here let's go back to the part B. Okay, so for a time from 0 to 300, at what time is the number of people aligned at the minimum? To the nearest whole number, find the number of people in line at this time. Well, the first thing that I'm noticing is at what time t is the number of people in line at minimum, meaning I need to find the derivative of the number of people, and then I need to find when that's equal to 0. And then, of course, I probably have to justify that that's going to be a minimum. So let's go back to part D. Actually, I'm going to move and I'm going to talk about, this was my equation. Let's just use this one. This was my equation for the total people at any given time, x, from 0 to 300. So 0 less than or equal to x, less than or equal to 300. Well, let's take the derivative. And what we get is r of x minus e of x, which in this case, I guess what we can say would be 0.7. And we have to find when it's equal to 0. So 0.7 is equal to r of x. We need to find when r of x is equal to 0.7. So we have to go to Desmos. And then I guess what we could do is I'm going to do r of x minus up on top minus 0.7. And then I'm just going to find when it's equal to 0. And you just zoom out from your function, and we find that it's at 33.013. So x is equal to 33.013. Okay. So now we just have to find the total number of times. So we have to find, I guess, t. Oh, I guess we should justify that will be the case. That's going to be a minimum, because that's really the only time. So we need to find r double prime, or I guess just r prime, because that will be the second derivative, at 33.013. So let's go to Desmos real quick. And here's the cool part. You can just do r prime of 33.013. And it is a positive. That's a positive. So what does that mean? If it's positive, I guess we could just say it's positive. Therefore, it is going to be concave up. So it is a minimum. And then so now all we have to do is find the integral from t 0.13. So we're finding the integral from 0.0 to 33.013 of r of t minus, and then I'm going to do 0.7 dt plus your 20. Don't forget, you have to include your 20. So going back to my slideshow, we're just going to do, instead of 300, we're going to do 33.013. I realize you can't see that. Guys, I'm sorry. I don't know why it's just like flipping on me like this. 33 point, whoops. There it is. Negative 19. I don't know if that was the correct answer. You have to add 300. Yeah, let's talk. Oh, I have to add 300. So let's talk about that. Yes. So going back to, thank you. T was equal to 286 time. Answer key was 414.286 for part C. So for part C, what did I have to find for part C? What is the first time that there are no people in line? Oh, yes. So the reason why that's the answer, and let's go back to that, and I would have gotten points off for that, was because this was the time from 300 to 300 onward, but I found this time to be from 300 onward, so I need to add 300 plus 114.285. Ooh, that was pretty bad. So again, from part C, we just were looking at the time from 300 onward. So we had to add that to the original value because it was 114 seconds after the 300 seconds. Yes, thank you for fixing that. Okay, so hopefully I got part D correct. Somehow, I don't know, I got mixed up. I was reading the comments there, but hopefully that is okay. I think we should do another FRQ from 2019. Thank you. Um, let's see. I want to just go back to the problem here. So for part D, I use this one. I found when it was a minimum. So we showed that it was a minimum at 33.013, and then we found the value. Okay. So let's talk about another problem that this person keeps giving problems. Thank you. W. Okay, here we go. This is the problem right here. We got question 6, and I'm assuming this is no calculator portion, so we got no choice but to deal with that. All right, so f, g, and h are twice differentiable functions where they tell you g of 2, h of 2 is equal to 4, and then we have the line that is tangent to both the graph of g at x is equal to 2, and the graph h at x is equal to 2. Very interesting problems. So we need to find h prime of 2. I want you guys to think about that one. I feel like that one's pretty easy. So we're doing part A. Part A here. And they tell us that g of 2 and h of 2 is equal to 4. The line is tangent to the graph at x is equal to 2 for both g and h. I'm curious what you guys would choose for part A because that one is very, very simple. Let me know what you guys think. Part A. All right, let's talk about it real quick. If we don't know, that's fine. Yeah, so someone said 2/3. So the problem with this is I noticed that they even mention it. The line y is equal to 4 plus 2/3 x minus 2 is a tangent to the graph at x is equal to 2 for both g and h. So at h, this is the line that's tangent to the graph. So this is the slope. The 2/3 is literally just a slope. So h prime is quite literally, or h prime of 2 is equal to 2/3. And that's going to be important because they're going to ask something about that in part B. Let me go ahead and start sort of writing this down, and then I will show you guys my work. So for part B, they give you a function a of x, 3x cubed h of x, and they want us to find h prime of 2. Now, guys, if they give you this on the AP exam, that is amazing. Okay. Oh, I got a bit of a delay. Hopefully everything is fine. Let me know if it's good. Hoping that let me know if I'm good. Okay, so hopefully the delay is gone. I'm really hoping that that's the case. But anyway, when we take this derivative, you got h prime of x. You have to apply the product rule. So we got the derivative of the first function. So let's just go ahead and do 9x squared h of x plus 3x cubed h prime of x. So now we go ahead and plug in the 2. H prime of 2, 9 times 2 squared, h of 2 plus 3, 2 cubed, h prime of 2. Now remember, whoa, they're asking us quite literally for h prime of 2. And then we were told this was given to us. This was 4, and this was 2/3 from the h prime of 2. So if we get a wrong, then that's not good. right? So continuing onward, we get 9 times 4, so 36 times 4 plus 3 times 8 times 2/3. And I'm wondering if you can just leave it like this. I'm really curious if you can just leave it like this. But this will be 144 plus, from here you can technically just cancel out the 3's. Again, try to make it as easy as possible for you guys or for yourself. And then so we have 144 plus 16. And I think this will be 160. And one thing I'll say, that if you get, like, let's just say you make a mathematical, like just an algebraic error there, instead of 144 plus 16, you put like, that's 170. I think that's going to be fine. Your grader should look at the previous work and say, that's fine. Okay. If someone says, and then I got 2021. Yeah, right? Oh, I know what you're saying. Yeah, so that's part B. Let's go to part C real quick. God, if they give you this, easy points. You guys should freaking be celebrating. I want to see this. I want to see this. Tell everyone in the class. Let's go. That's what you tell them. Because, guys, this will be so simple. Okay, I'm going to write the function x squared. I'm going to part C. Oh, I should have just gone to the actual problem, but I'll go back to it real quick. So they give you h of x, which is this, over 1 minus, and then we have f of x cubed. And then let's go back to the problem. So we have the function h satisfies h of x. It is known that this limit can be evaluated using L'Hopital's rule. And I'm assuming then it's because when you plug in 2 on the top, you get 0, and on the bottom, for some reason, you get 0. Okay? Use h of x to, or use this limit to find f of 2 and f prime of 2. Ooh, that's interesting. That's a good one. So again, they're saying that it is known that L'Hopital's rule can work. So that must mean, okay, first of all, I'm going to go back to this. We need to find f of 2 and f prime of 2. Well, if L'Hopital's rule can be used, first of all, that means that x squared minus 4 is equal to 0 when x is equal to 0. So if you take the limit as x approaches 2, well, we're going to get 0, and that's true. And if we take the limit of the bottom, which is 1 minus f of x cubed, then that should equal to 0. So that means 1 minus f of 2 cubed is equal to 0. Because again, that means, because they're saying that L'Hopital's rule can be applied, so the top and bottom has to be the same. Well, that means that we have f of 2 cubed is equal to negative 1. We take the cubic root. F of 2 is equal to just negative 1. There you go. Well, then after this is saying, all right, now we apply L'Hopital's rule, the hospital rule. So we have the limit as x approaches 2. So let's take the derivative of the top. So that'd just be 2x. And on the bottom, we have negative 3 f of x squared times f prime of 2. Now, apparently this limit exists. Well, we know h of x. From the very beginning, it told us h of 2 is equal to 4. So this limit, when x approaches 2, should equal to 4. Someone said, isn't a positive 1? Ah, yes. Oh my gosh. Dude, I'm sorry. So it is positive 1. Why? Let's talk about that real quick. Going back to this problem. So here, this is what happens when I don't show that work. When I subtract the 1 and then I divide by a negative 1, because technically it should have been a negative right off front here. So let me just go ahead and just do that real quick. So f of 2 cubed is equal to 1. So then f of 2 is equal to 1. Thank you. I would have gone points off. And that would have been my bad. Thank you. So screw all that. Oh, I didn't. Why is it erasing? Good Notes is doing this to me. There we go. All right. So once again, we knew that that h of 2 is equal to 4. So 4 is equal to, now let's go ahead and plug in 2 in here. So 2 times 2 over negative 3 times f of 2 squared. The good thing is that even if I got the f of 2 incorrect, it would have been fine for this one. But still, easy points that you can miss because you're going to square it. Okay, so we have 4 is equal to 4 over negative 3 times 1 squared, because f of 2 was at 1. And then this is what we have. Let me just simplify this. 4 is equal to 4 over negative 3 f prime of 2. So that means that the bottom has to equal to 1. So hopefully you can kind of see the math here that f prime of 2 has to be negative 1/3. Thank you for saying that. The very first person that mentioned the 1, not going to say their name. Something 3084. All right. Not bad. All right. We got one more problem, or one more section for this problem right here. Let's go to part D. It is known that g of x is less than h of x for values 1 less than 3, or 1 is less than x less than 3. Let k be a function, guys, let k be a function satisfying g of x is less than or equal to k of x less than or equal to h of x for values 1 to 3. Is x continuous at x equals 2? I want to hear from you guys. And the person that's been here from the very beginning should know that whoever sent this problem, I feel like this was on their mind. We just talked about this. What do we think? Is this function continuous at x is equal to 2? That, I like this one. I'm going to write out my work real quick. But I want you guys to let me know in the chat what you think. K of x less than or equal to h of x. Ooh, someone said IVT. That's technically, is x continuous? You know, I feel like you can argue IVT. I'm not gonna lie, just because you are showing whether a function exists at x equals 2. But I feel very much in my heart that this will be a squeeze theorem. If someone wants to check the answer key to that one. Ooh, MVT. Well, remember, Russian Penguin, that MVT talks about the derivative. So if they were to ask, does a derivative exist that, or is the derivative equal to this between this interval? Then we would be using MVT, because that's what the mean value theorem tells you. So squeeze, the sandwich theorem. Someone in different countries mentioned it. Mentioned that it's named something different, but for us, we're gonna call it the squeeze theorem because that's exactly what it is, in my opinion. Yes, I did speak about the squeeze theorem earlier, and I think this is exactly what it is. So for example, if I take the limit as x approaches 2 of g of x is less than or equal to the limit as x approaches 2 of k of x, because remember, that's what continuity means, that the limit will exist, the function will exist, which they kind of already mentioned that it does, and maybe we can justify it a little more. Now, they don't necessarily tell us this, but they tell us f, g, and h are twice differentiable. So we can already say that they're continuous at 2 because they tell us g of 2 and h of 2 is equal to 4. So I'm going to go to my drawing board over here. And this is equal to 4. We don't know what this limit is, but we know that the other one's also equal to 4. So we will say by squeeze, even give it a little squeeze theorem. I'm sure they'll appreciate that. Limit as k approaches 2 of k of x exists, and k of 2 is equal to 4. So k of x is continuous at x equals 2. Yeah, don't worry. So something 3084. When it comes to this, just keep in mind, when they give you functions that are squeezed in between it, again, this inequality where you have g of x is less than k of x is less than h of x. So immediately when you see something like this, I want you to think about squeeze theorem. In fact, I hope that it shows up on the exam so that you can just go back and tell your teacher, you didn't teach it to me, but I saw it on a live stream with a bunch of other nerds, and I know what it is. Okay. That name, crazy. All right. I got time For one more, it looks like it potentially is an FRQ, but let's just talk about this because this does touch on units 1 and 4. And don't forget, I will say that I will be. You can, by the way, join the Discord, post as many comments or questions as you like. There's people there that are actually studying with you guys, so please do that. And at the same time, I will be live streaming tomorrow night. I think it's like from 5 to 7, and then if we need more help, we can talk about it and we can probably do a later time. Okay. Just to answer a question here, someone's asking, when can we use IVT and squeeze theorem? So IVT is basically asking you whether or not a point exists between a function. So let me just go back to the board over here. The reason why squeeze it was probably more suited for this problem is because they tell you the inequality. Okay. But let's just say, for example, typically they can give you a function. I don't know. They can give you a table. Let's just say we have x and we have f of x. So we have 1, 2, let's just say 5, and I'm going to go to 10. This is 6. This is going to be 8. This is 13. And then this is going to be 20. Okay. And then they could ask, I guess I should say, is there a C on, a C, I'm just going to write it kind of very similarly to the other problems, such that, is there a C where 2 is less than C less than 5, where f of C is equal to, like, let's just say 10. Okay. So the idea here is that the function is continuous. They will probably say that, but this is going to be where you use IVT. Okay. Because remember, intermediate value theorem, if you were to sort of draw this, f of 2 is here. Let's just say this is 8. This is 2. And then 5 is up here. Let's just say this is 13. Again, the whole point is that the function is continuous. So you have to state that. If the function is continuous, which they will state, does the value equal to 10 at some point? Well, here's 10. And sure, I mean, by drawing it, we can say that. But that's what IVT tells you. Does the value exist between the interval? And we will say, yes. We will say since we will say f of 2 is less than 10, which is less than f of 5. In other words, looking at the table, 8 is less than 10 is less than 13. By IVT, there is a C such that f of C is equal to 10. Well, and also we should state, because again, IVT, if we're going to use it, since all this happens, but also since f is continuous on the interval. So I'm just going to put like on 2 to 5. Okay, it's because the whole point is they will state that it is going to be continuous. They already mentioned it. Or sometimes they'll even say like the function is differentiable. And don't forget that when something is differentiable, then it is continuous. Yeah, I agree. Nice. I like that you got a 5. Jake. Wait. I think I know who you are. Nice to see you on here, Jake. All right, guys. We got one more on here that we're going to do, and then we'll be done. All right, we'll be done for the night. You guys can rest those minds, chill, especially those taking a push. They can relax. Tomorrow we'll do some more stuff, and then on Sunday, keep in mind, yes, I'll post some review stuff. But if you're on the Discord, I'm gonna be yelling at you at night to go to bed. So, yeah, that's what's gonna happen, because you cannot be studying on Sunday. It should be a taper day, and by that I mean you should be chilling on the couch, already thinking like, I got it. Let's see the derivative of this. Yeah, related rates, FRQs, light work. This is gonna be easy. That's all you got to be doing, guys. That's it. Okay. Okay. Before we do the FRQ, let's talk about MVT. Okay. So maybe I'm gonna go back real quick. MVT. Let's just say in this case, I have to give you a table. So let's just say, for example, this is X, and this is F prime. Okay, this is the difference. So this is once again 0, 2, 5, 10. This is 6, 8, 10, 13. I'm just going to kind of show that. And then, so I'm going to say, is there, well, and also I guess I should state f, well, since f prime is already given there, we would assume that it's continuous. We will assume that it's differentiable. All right, they have to state that, and we'll talk about how we would mention that in a second. Oh, wait, you can't hear me? And then, so I'm going to say, is there, I'm listening to the stream, and it looks fine. Oh. Okay. So we're going to talk about MVT. So is there a, okay, thank you. Is there a C on, let's just say, for example, 2 to 5, such that f prime of, I guess I should. This is why I can't make these problems up. I have to just find them. So this should be the original function. But going back to this is the difference, right? IVT was asking, is there a function or is there a value where the function is equal to this? Now they're going to say, is there a C where f prime of C is equal to, let's just say, for example, 2/3. Okay, well, first of all, remember, this is what IVT tells you. So they're just saying that if I were to draw like a function, this is, here's 2, here's 5, here's 8, and then, whoops, here's 8, and here's 10. So again, we don't know how this looks. Is there a point where the slope somehow is 2/3? And what you have to do is you have to find the slope between the 2 points that they're referring to. In this case, we're talking about 2, 8 and 5, 10. Well, first you have to say f is continuous and differentiable. Okay. A lot of the times we can just say like given, right? And now we have to say f of 10 minus f, whoops, not f of 10, f of 5 minus f of 2 over 5 minus 2. And let's see, f of 5, you can look at the table, as 10 minus f of 2, which is equal to 8, over 3. So we have 2/3. And look at that. The slope between the 2 points, going to the graph, the slope between the 2 points, in other words, if we were to form a secant line, there is going to be a line that's parallel to this blue line. So the red line will be parallel to this blue line. That's what the MVT tells you, that if the function's continuous, if we can draw this without any lines or breaks, then this secant line is going to be parallel to some tangent line somewhere in the graph between this interval. So then what we just say, by MVT, there is a C on 2, 5 such that f prime of C is equal to 2/3. So remember, MVT or IVT was just, is there a point in between those two? MVT is there a way that the derivative is somehow equal to this? Yeah, someone mentioned closed. So closed on, again, you're right. Closed on it has to be continuous on the closed interval because they can't have any holes. And it has to be differentiable on the open interval. The thing that I'm going to tell you is on the AP exam, they don't really care about that. Okay? Because they're already going to tell you that it's differentiable, that it's continuous. They're not going to necessarily care so much. It'll already be designed for you. So you can just say f is continuous, f is diffable. In my opinion, I think that's totally fine. Okay? Okay. Let's go to the final problem for tonight. And don't forget, after this, you can rest. I'm going to see you tomorrow. We'll go on the Discord. We'll chat there. And yeah, no Sunday stream. Going to be yelling at you guys. You got to go to bed. That's just what it is. Awesome. So here we have a problem. Who suggested this one? Okay, so I'm going to... someone suggested another one. I'm going to pin it so we could do it tomorrow. Okay, I'm going to pin this. But someone suggested, this person keeps giving some good problems. Let's go. Okay, so number 6, you have a function that's continuous on these intervals. Okay, show that f is continuous on x is equal to 0. To be honest, I don't quite see this as an FRQ, but let's just talk about this, right? Because it's like definition of continuity. So remember, with continuity, the first thing that we got to do is f of, since we're talking about 0, f of 0 is defined, meaning that it exists. So we have to go to our function. And at 0, the only the interval that we should be focused on is the first one, because x is less than or equal to 0. So if you plug in 0 on here, 1 minus 2 times sine of 0, that's just going to be 1. So f of 0 is going to be 1. And now we have to find the limit as x approaches 0 from the left. And we have to find the limit as x approaches 0 from the right. Well, let's go to our picture. And when it's approaching from the left, we're looking at the first function because it's x is less than or equal to 0. So when you're looking at 0 to the left, it's less than. So that's what we're really looking at. We're just going to plug in 0 into that one. We already know it's 1 because that's what we plugged it into in the very beginning. So we know that's 1. And now we have to check the other one. Let's go ahead and plug in 0 into that one. Now I know that it's greater than, not greater than or equal to 0, but it's okay. We can just plug in 0. Again, you're technically plugging in something really, really, really close to 0 on the right, like 0.00001. You can just plug in 0. It's totally fine. So when you plug in 0 into that one, you get e to the 0, which is 1. So far we're good. It's defined. The function is approaching the same value from the left and right. In other words, the limit as x approaches 1, f of x, is equal to 1. It exists. Because remember, that's kind of the whole point, that a function is going to be defined. Okay, or a function is going to be continuous. The limit from the left to right has to be the same value, has to exist, and then f of 0 has to be defined. And in this case, for step 3, f of 0, by the way, I'm going to change this. It shouldn't be limit as x approaches 1. It should be x approaches 0. Okay, so f of 0 is equal to the limit as x approaches 0 of f of x. Therefore, I guess we can say f of x is continuous at x is equal to 0. Yeah, let me write this. Continuous. There you go. Not bad. Not bad. Someone said, yeah, you can just both say equal. Yeah. So you can totally send them equal to each other. That's totally fine. Honestly, I don't think they're gonna be too worried. This is just the way that I know some calculus teachers get really meticulous about how they want you to write it. This is just the way I was taught, so that's how I wrote it. But I think you can just put this is equal to this, put it equal to 0. It's continuous, because that's kind of what I had done in an MCQ where I just set it equal to each other, and that's totally fine. So yeah, not a problem. Okay, so for the last one, for x not equal to 0, express f prime as a piecewise defined function. Find the value of x for which f prime of x is equal to -3. Okay, so let me just write the piecewise function on my pad over here, and then I will take you to it in a second. X is less than or equal to 0. X is greater than 0. Okay, so remember, they're basically just mentioning x is not equal to 0. Let me just write this a little better. Okay. All right, guys. There you go. There you go. Switching back and forth. I should have some buttons. You know, that'll be much easier. But anyway, let's go ahead and take the derivative. So we're just taking the derivative of this function. I'm assuming this is definitely a no calculator portion. It's problem 6 if that's the case. So this will be the derivative of 1, 0. So -2 cosine of x for x is less than or equal to 0. And then we will do -4 e to the -4x for x is greater than 0. Not bad. The piecewise continuous. Okay, so find the value for when f prime of x is equal to -3. So that's, notice the question. First of all, we found the derivative because they're saying express f prime. And now they want us to find x for which f prime of x is equal to -3. Well, what we got to do is just go ahead and plug in the 3, or set the equation equal to 3. So let's see. -2 cosine x is equal to -3. In other words, cosine of x is equal to 3/2. Bro, okay. I mean, I guess. And then so x is equal to arc cosine of 3/2, or otherwise known as cosine inverse of 3/2, depending on how you prefer that. And then we do the other one. -4 e to the -4x is equal to -3. E to the -4x is equal to 3/4. And then we take the natural log, so -4x is equal to natural log of 3/4. And then x is equal to natural log of 3/4, I guess, divided by -4. I'm just going to leave it like that. Did I do that right? It just seems like it's whatever, That's really interesting. That's honestly really interesting. I'm assuming, and find the value of x, I mean, is cosine, I guess what we can say, cosine inverse of 3/2 is 1.5. You're right. Thank you. And I'm like, okay, let's look at that. This is what will happen on the AP exam. You will write it and think like, is this good? Am I done? But someone mentioned this does not exist because cosine of inverse has to be, or the input has to be between -1 and 1. So if it's greater than that, so we're good. So then the only solution that we will have is this one. Yeah. Okay, and then we got the next one. I think this feels like a Calc BC problem, and you'll see why in a second. Because now they want you to find the average value. Let's go back to the picture. The average value of f on the interval -1 to 1. Now, how do we find average value? Well, average value is known to be 1 over b minus a, integral from a to b of f of x dx. This is what's known as the average value. Yeah, Russian Penguin, I was the same way. I was going to be like, okay, I guess I'm done. But this is one of those things where you stop yourself and ask, is it actually right? So I guess we just got to, if they want us to find the average value of this function, f of x, from 1 to 1 minus 2 sine x, and then e to the -4x. Now, the thing that you have to keep in mind is this is defined, like, for example, we have to technically do two different values. We have to do two different values because it's the interval from -1 to 1. So we have to split this up because remember, look at the inequalities. One of them is less than or equal to 0, and the other one is greater than 0. So I think what we have to do is split it up. So we'll have 1 over, and then we'll have 0 minus -1 times the integral from -1 to 0. Because again, this was my a value, this was my b value, so we did b minus a over here. And this one's fine. Oops. This one's totally fine. We can just do that, and then this is 1 minus 2 sine x dx. And so this is 1 over 1, so we can just ignore that. And we have the integral from -1 to 0 of 1 minus 2 sine x dx. But then don't forget, we also have to do plus, and now we have to do 1 over 1 minus 0, and we have to do the integral from 0 to 1 of e to the -4x dx. The issue that I have with this is that technically 0 is not defined, so I have a feeling we're gonna have to do like the limit, and I'll show you that in a second. We're gonna have to do plus the first fraction over here is just 1 over 1 still, so I think we have to do the limit as b approaches 0 from b to 1 of e to the -4x, only because b is not defined. I don't want to call you out, but you know who you are. If you wrote that down, let me actually message them and ask what year was this, or was this BC? Maybe I'm asking them on the Discord just because I want to know. I was thinking the integral from -1 to 1, but don't forget, technically, there's two different functions. It feels like it's an improper integral. Let's just do this one real quick, and then, we'll see what the answer is. 2011. Oh, it's an AB problem. Okay, so we're gonna assume that we can just put 0. I think what we could just do is the integral from 0 to 1. Okay. We're not going to do an improper integral only because this is apparently AB. And with AB, you're not doing anything like that. Okay, so let's just start integrating. The first one is going to be x minus 2 plus 2 cosine x. Again, if you integrate that correctly, that's what you will get. Negative 1 to 0 plus, and then the other one is going to be negative 1/4 e to negative 4x from 0 to 1. Post boys, why can't it be 0? Well, in the very beginning, actually, I have it here. Notice that they mentioned that x has to be greater than 0. So technically, the function wasn't defined at 0. So that was really the issue that I had, that we don't know. Oh, however, let me take that back. Maybe this is why you're allowed to do this. Maybe I'm confused. In part A, we show that the function is continuous at 0, meaning it has the same point. So we're good. I think the way we're doing this was perfectly fine. So we're justified. And then how do you get negative 1 for the lower limit? The question was asking, let me go back. The question was asking to find the average value of f on the interval from negative 1 to 1. So what we did is we split it into two different values. So we had to do a negative 1 to 0 and then 1 to 0 because we have a piecewise function. Okay, so let's continue. This is a no calculator portion. So now we plug in 1. Actually, let's plug in 0. Let's start off with, I'm going to circle this. We're going to do the ones in red. So we have 0 plus 2 cosine of 0 minus negative 1 plus 2 cosine of negative 1. And then we'll do the other one just to fit it on here. So we'll do the blue part. That'll be plus, and then we'll do negative 1/4 e to the negative 4 minus negative 1/4, so plus 1/4 e to the 0. So let's just simplify this. Well, for the first parentheses, I think that's just going to be 2 because 0 plus cosine of 0 is just 1. 2 minus, and then this next one, I think this is going to be negative 1 plus 2 cosine of 1. Now remember, cosine is even, so I just forgot about the negative there. And then we have minus 1/4 e to the negative 4 plus 1/4 because the e to the 0 is just 1. So if I were to simplify this, I mean, I would just leave it like this. But if I were to simplify this, I wonder if I can make this a little smaller. I guess I can't. Let me change it up. I'm going to write my answer up here on top just because I have space. And I want to make sure everything's on the screen here. So this will be 2 plus 1 minus 2 cosine of 1 minus 1/4 e to the 4th plus 1/4. So I guess 3 minus 2 cosine of 1 minus 1/4 e to the 4th and then plus 1/4. Oh, this was a little messy, but that's honestly how I will leave it. Wow. Wow. This was an AB problem. I mean, I get it, but it was apparently from 2011. Oh my goodness. I won't even tell you, but I took this exam, both the AB and both the BC. And I'm curious what you guys think. What I got on the AB and the BC and what year I took it. That will be the question for you guys. But chat, that's it for today. That is it. This was fun. Hopefully you guys kind of know the rundown of this. Tomorrow, I think I will do this a little bit later. I don't know if you guys are East Coast or West Coast or Central Time, but go to the Discord. Again, you guys can go to the Discord here where you guys can chat with other AP nerds. 2003, no. 1998, no. And I did get a 5. Yes. But yeah, guys. So you guys can go on the Discord, talk to a bunch of people on the AP channel, and that's where you guys can post your questions. I'm gonna continue posting videos on Instagram and on TikTok if you guys want to follow me there. But tomorrow it will be another live session. I think around 5 to 7 or 6 o'clock, maybe a little earlier than that. And if we feel like we need to drag it on, then we'll do that, and then we'll finish it up. Um, but yeah, let me answer some few questions, and then from there, we're just gonna call it. Someone's asking, is Barron's review good for problem practice? To be honest, I'm gonna tell you, you guys are almost at crunch time. I would suggest do as many problems as you possibly can. Barron's is perfect. I think that's great. That's honestly going to help you prepare. My best suggestion is to do a previous, especially FRQs, previous FRQs. For the MCQs, I think that's great. I think that's perfect. Okay. So it'll be 6 p.m. Pacific. So Mountain Time would just be an hour later, I think. Yeah. But anyway, the year that I took it was 2007. Not bad. You guys were close. 1998 and 2003. Nice. Um, yeah. So someone was saying that Barron's is different than the College Board, and I completely agree. I remember when I studied for the BC exam using Barron's, and it was just not for me. So I would highly suggest, again, you guys have so many resources, but I think for Barron's the MCQs are perfect. I think that'll be a good practice for you guys. But yeah. Um, what are some good sites? Khan Academy is great. If you go to the Discord, there are a lot of pinned comments that people have posted that just have a bunch of review. At this point, the best thing for you to do is just review as many problems as possible. Seeing little things like, oh, that's right, I should have used MVT there, IVT in this one. I think that'll be great. But that's how you review. To be honest, there's no secret formula. Everyone reviews things differently. So I would suggest find what works for you and just kind of run with it. But what I did is I just practiced as many problems as I can. That was just it. Yeah, the Princeton review is good, and the sub score, I'm not quite sure, but I think what they do is they'll say, okay, you took AB material. This is what you got for that score for basically units 1 through 8, and then after that, 9 and 10, I believe, they'll say this is what you scored on that one. But it's just going to be a sub score. To be honest, I think the total score is going to matter. Um, yeah. All right, guys, this has been fun. I really enjoyed it. I'm glad that I had a game plan that we were going to do just unit review, but the more people posted problems, the better. That's really just the way it works. You guys run the show. But okay, I'm going to head out, and I'm going to see you guys later. I hope you guys have a fantastic evening. Go relax. You did a lot of work today. But again, you guys could always follow me on Instagram, YouTube, Discord, or TikTok. We're all there. And go chat with a bunch of math nerds on Discord because they're getting ready. They're getting ready just like you are. All right. Perfect. You found the Google Drive. All right, guys. I'll see you guys later. Ta ta. Ta ta. Ta ta. Take it easy.